And you should see a little red dot on your end indicating that it's recording up on the top right, if your screen is the same as mine. Okay. So if we look by the way, just jump in if you have any questions. I have some instructors are really kind of narrow-minded regarding students asking questions or interrupting, whatever. I have no problem with you asking questions, so feel free. Okay, so a couple things. This is the lecture and lab schedule. Now, what's kind of weird is next week, Monday, we have off. So I might revise this a tiny bit. Now, there are two kinds of labs. We've got wet labs and dry labs. Dry labs are basically worksheets. Wet labs, you'll have chemicals out, like your first wet lab is with alcohols and phenols. And that'll be towards the end of September. And you're going to have a specialized pre-lab write-up for wet labs. So between now and the end of the month, end of September, you need to pick up a few things. One is goggles, and the goggles that are only allowed are Uvex Stealth. And you can get those at the student store, which is the most expensive. You can go on Amazon and get them. You can borrow a pair of a friend that had this at class before, or 305 before. And you also need a lab coat. Now, lab coats can be in any color you like. The main thing is it has to cover down to your mid-thigh. Also, you need close up shoes. Basically, if I can pour boiling water on your shoe and you don't feel the boiling water, they're fine. If they have holes in them on the top or anything like that, they're not going to be allowed. Now, these are required. Closed-toed shoes that have no holes in them, Uvex goggles, and a lab coat. Now, I'm giving you plenty of time to get those. Now, if you forget them, you can rent them at the stockroom. I'm assuming they're still doing that. They did it last spring, so I'm assuming they're continuing to do that. Okay. So basically, what we'll probably do for Monday, a week from today, is there's a dry lab. And as I was saying before, a dry lab is basically worksheets. So I'll probably have you do that at home. And then if you want to come on Wednesday as well, that's fine. And join the Wednesday group. Our lab room is 316, which should be the same room as 305. So anyway, this is the schedule. Now, notice that the tests are going to be given in the lab section. So dry lab number 3, you're going to do at home, and you're going to take the test that day, whatever your lab schedule is. Monday, Wednesday tests are different. They're slightly different. They're not the same. You may, once you finish your test, you may, if you want to finish dry lab 3 in class, that's fine as well. Anyway, this is the schedule, and one of the tests is going to be online. That's test number 3. Other than that, the tests were all in the lab section. Now, the final, because of the odd way this class is set up, I can't get a room for test 5. So that may be an online test as well. So I'm not, it's to be determined. So I don't like doing online classes because everything gets screwed up. Okay, so any questions about the lab schedule? After 8 weeks, we have a recess where there's no lecture or lab. You have a week off. There's also a research project, and I can talk about that at length after we get done with the syllabus. So are there any questions about the lab schedule?
I do.
Yeah.
So lectures are both Monday and Wednesday, and labs are only the day that you're assigned, correct?
Correct. So
Okay.
exactly. So lectures are both Monday, Wednesday, Zoom at noon. And labs are whatever day you signed up for, Monday or Wednesday. Now,
Thank you.
Say you can't make, you're in a Monday lab and you can't make it, just go to Wednesday. Usually we have plenty of room.
Thank you.
Then if you miss a Wednesday lab though, you can't make up, if it's a wet lab, you can't make it up. So we have to make other arrangements depending on the reason why you missed the lab. Okay? Okay,
Professor, I have a question.
sure.
Can you hear me?
Yeah.
Awesome. I have a question about the test. So I was going over the syllabus. I couldn't really point out how you like to lay out your test, like how many multiple choice, short questions, fill in the blank, and just so I can study ahead of time so I know what I'm expecting in the test.
Right, right. That's a good question. I don't do any multiple choice because I like to give partial credit, and multiple choice is either right or wrong. And I provide practice tests for you as well. So when we get over to Canvas, I'll show you where they are. And just remind me if I don't show you where they are, okay?
Okay, thank
And
you.
sure, the practice tests are very similar to the test you're going to get. Basically, what I do is I take the practice test and modify it. I don't believe in trick questions. I don't believe in giving you a test on something we haven't covered in lecture. Hopefully this class is very straightforward. If I was a student, that's the way I would want it. So I try to think about how I would react in my own class.
Awesome. Thank you.
Sure. Okay. All right, so let's talk about the syllabus now. Okay. Most of the time, students want to know two things in the syllabus. By state law, I have to include a whole bunch of other stuff that students are not interested in. But basically, how to get a hold of me. The easiest way is through Canvas messaging. However, if you're using, if you're sending me an attachment, don't use Canvas messaging, use Outlook. And the reason for that is Canvas messaging, in my experience, has been marginal in terms of including the attachment. If you use Outlook, it's very rock solid. It always goes through. So if you have a question, usually I like you to take a screenshot of it so that I know what you're talking about, because it's hard to describe otherwise. And then we can either do a Zoom session, and that can be a group Zoom session if you are in a study group and all have the same issue, or it can be individual. Okay, here's my email address up here, as you can see. Our labs start at 3. I will be in the lab by 2:30 at the latest. So if you want to come by and ask questions or something, you're more than welcome to come by early. But labs typically start at 3. They don't usually go to 6. The dry labs never go to 6. What most people do is they go through the dry lab and do most of it and finish it up at home. That's fine. You can also do it in the hallway. You don't have to be in lab to do it. Wet labs, it depends on the wet lab. Some of them can go really long time. Your second wet lab is you're going to be taking orange peels and doing a steam distillation on the orange peels. And that's a lot. That's probably the longest lab. Other than that, though, you know, the labs don't go 3 hours. They can if you want. I'll be there, so. Okay, so contact information. If you want a Zoom session, um, contact me before I leave for school. Right now I'm at home, it's my home office, and I usually leave here at at around 2 o'clock. So I get to school about 2:20-ish. By the time I get up to the room, it's 2:30. And unless there's traffic issues or something like that. Now, the prerequisites for this class are chemistry 305 or equivalent. Now, 305 basically is a allied health inorganic chemistry class. It is taught at all the community colleges in the area. The Sierra equivalent is 2A. It's exactly the same class as this 305. And there's also a similar one at Sac State, but you just need, excuse me, you just need prior knowledge of inorganic chemistry. Now, I'm going to go over some of this stuff today on writing Lewis dot structures. You're going to be doing structures for the whole semester in here. In fact, you're going to be doing every single time you do anything in here, you're going to be working with structures. So it's really important to know how to do a Lewis dot structure. And it's going to be a very focused Lewis dot structure as well, not just a generic one. It's going to be focused on organic and biochemical structures. Okay, so that's the big deal on why you need to take 305. Okay, are there any questions about contact information? Okay. Okay, so as far as requirements in the lab manual, or the lab class, part of the class, again, and that's the UX stealth. Basically, what we did about 1.5 years ago is we tested all the chemical splash-proof goggles typically available, and we found some of them didn't work very well. They were approved by the vendor that sold them, but it didn't work. So the UX Stealth are the least expensive. They're the most comfortable also. The cheap ones are very uncomfortable to wear. And if you've already taken a chemistry lab class, you probably already have a UVEX Stealth equivalent. If you've taken it at Sac City, if you've taken it at another school, I need to see them before you can use them in class. Long pants are a suggestion. It just covers your bare lower leg, but they're not required to have long pants. You can wear shorts. I wear shorts until it gets cooler. I already mentioned closed-toed shoes. This is called a closed foot shoe, meaning there's have to have a back on them. Lab coat or apron. Most people wear lab coats. Doesn't have to be white. Mine is tie-dyed. Aprons are not as good because it exposes your arms. But you can wear an apron as well if you'd like. Now, you're not going to need a scientific calculator in terms of logarithms and scientific notations. This syllabus, I had a copy from the department chairman, and he liked to have their students have logarithms and scientific notation available. We're not going to be doing a lot of calculations in here. We are going to be doing some, but not a lot. And if you need one with, for sure, we're not going to use logarithms. Scientific notation, we probably will be using somewhat. So if your calculator has scientific notation on it or an EE function, even better, that'll be fine. Okay. And again, this is for wet labs only. Dry labs, you don't have to worry about any of this stuff. Okay. Now, there's a lot of material in this class. There are 5 units, and there's a lot of memory in this class. You've got to memorize structures, particularly on the biochemistry side. Now, each unit has got an organic and a biochemical component to it, except Unit 1. Unit 2 onward has both those subunits in it. Unit 1 is on alkanes, alkenes, alkynes, and alcohols. Unit 2 is on ketones and aldehydes, and that's the chemistry of carbohydrates. And so that'll be your first biochem unit. I highly suggest getting in a study group. I've done a lot of research. I used to be a MESA advisor, and the MESA organization has done a lot of research on study groups. Student achievement through many, many, many studies has shown to be much higher if you're involved in a study group. So highly recommended to get involved with one. If you're a lone learner, you can still benefit by joining a study group. I know some people they don't like to be around other people. They like to do their own thing, which is fine. I'm just saying though that study groups, even for those individuals, your achievement will go up. Okay. I'm going to talk about your lab write-up in detail. Between now and the first wet lab, you're going to need to pick up a lab book. And the lab book is just a comp book, and the pages have to be sewn. They cannot be spiral or a 3-hole punch. You can use a tablet though, if you like. The whole write-up is going to be handwritten, so you have to have a way, if you're going to use a tablet, to be able to hand write that information in there. You're going to have a lab partner or partners, depending on which lab we're doing, and you're going to share a drawer. Okay, I'm going to go over safety in the lab when I talk about the lab write-up. As far as the research project goes, that counts a test. It's one of the nice things about this class is you get to actually study something you're interested in and get credit for it. Rarely in your schooling you're going to be able to study something you're interested in and get credit for it. I've been doing this for many, in fact, upwards of 2 decades, having research projects in my organic class. And I've got lots of examples I'll show you once we get into Canvas. Okay. Disciplinary action, it's standard. Basically, don't cheat. Be honest. Okay. How I grade. Each test is worth 100 points, and those are percentage points. So whatever the raw score is, I convert to percent. You have 5 tests, and the 5th test, each test starting with number 2 is like a final because it includes prior information. So there really isn't a true final because every test, except for test 1, is a final. You're going to get 10 points per lab. Last time I counted, there were 12 labs, and that may vary. Could be 110 points or 130 points, depending on how many labs we end up with. Sometimes labs are canceled for inclement weather or power outages, for whatever. And there's 2 things which are the easiest way to get points in here is the lab waiver, which you had to submit in 305. And then I don't know if you submitted a lab safety contract or not in 305, but that's going to be needed as well. And there's an assignment in Canvas as to both of those. And basically, you click on it, download it, sign it, scan it, upload it. Now your final and test 5 are the same. Okay, if you have an accommodation, please make sure you communicate that to me. There's not a problem. Any accommodation you have, I will go to great lengths to make sure you're accommodated. Okay. Now, there's an optional textbook available, just like it was optional textbook in 305. It's the same one, only we're going to be using the second half of the book instead of the first half of the book. And these are the chapters we're going to be going through. Okay. Excuse me. So, are there any questions about the syllabus? Grading?
Yes, I have a question, Professor. Will you be providing any extra credit this semester?
Yes. I forgot to mention that. Basically, on test 2, I'm going to allow you to correct your mistakes for half credit. So say you got a 60%. That means you missed 40% of the test questions. Theoretically, if you redo the test questions and get them all right, I'll give you 50% rebate. That means you'll go from a 60 to an 80. Okay? Does that make sense?
Yeah, thank you.
Okay.
I had a follow-up question, actually. With that, is it only for exam 2 or is it from exam 2 and on?
For sure in exam 2. Possibly from then on. I'll have to see how things go. Normally I do it for test 2 only. But in the past I've thought about doing it for further tests. And I just may try that out this semester. In fact, I'm to make a decision right now. Yes, all the tests except for test 1, I'm going to do it too.
Thank you.
How's that?
Thank you.
Okay. All right. Any more questions about the syllabus or the lab schedule?
Professor, I remember seeing an email saying that you guys are looking for a new vendor for the lab manuals. I
Correct.
think it was.
Yes. We have a vendor that has been identified. And tomorrow, I don't teach tomorrow. I'm going to be submitting to the vendor the digital version of the lab packet.
Okay.
In the meantime, when you go to lab today or Wednesday, I'm going to be handing out a printed copy of the first part of the lab packet.
Okay, and then
I
follow-up
forgot where your question was
question.
going.
Follow-up question. You said that we needed a sewn version, not a 3-hold of the lab manual, or is that what was that? I'm sorry.
No, your lab notebook.
My lab notebook. Okay.
Yeah. Now, this class is going to be very different in terms of what you're turning in for the lab from 305. I've never taught 305, but everyone tells me how the lab write-ups are done. The lab write-ups in this class are going to be very detailed. You have to write out the procedure, the purpose why you're doing the lab, etc. I'll go over all that in detail. And it needs to be, when I say sewn, it's like the traditional comp book. They're like $1.50 or $2. Sometimes they come with a grid, sometimes they don't. And then
you can purchase that at the store here on campus, correct?
Yeah, you can purchase those all over.
Okay.
Walmart.
I picked this up for 50 cents at Walmart.
Yep.
Oh, okay.
How much did you say?
50 cents.
Oh, I've never seen them so cheap.
Thank you.
50 cents. You're welcome.
Wow. Usually they're $1.50, which is still pretty cheap. Oh, by the way, funny story. That I used to teach up in Washington State for quite a few years, and one of my students talked their family into buying them a leather-bound lab notebook. It cost $90. $90 for a lab notebook you could get for 50 cents now. It gains you no points extra, nothing. Isn't that something? $90. So anyway, you're gonna be having to write it in indelible ink, like with pen. Anyway, I'll go over all that in detail when we get closer to the first wet lab. Okay, 50 cents. Everything's supposed to be going up these days. Wow. Okay, okay, so let's go ahead and go on to starting the actual content. Now, there's no official homework. Let me go into yeah, those here. Okay. See my lab coat tie-dye. You do not require a white lab coat. If you want to get a white lab coat, that's more than fine, but you don't need one. I had some students up at Sierra that they got together as a group and all tie-dyed them. They all got extra credit for tie-dyeing them. So, okay. I try to keep most things in modules. Here's the wet lab, pre-lab I'm going to be going over in a couple weeks. And these are the videos. Now these are from prior semesters. And what I do is when I'm done with the session, when I end it, it renders the session into a MP4 file, video file. And then I copy that over to YouTube. And then from YouTube, I get a sharing. And then from there, I go to Canvas pages, create a new page, and then I put it in modules. So I do that each time I record. And let me show you what it looks like. When you click on this, it'll go to the link, which is now, this is a page now, a Canvas page. It goes to the link, which goes to YouTube, and there we are. You can see them in YouTube. Now, you have access on this to all the videos. I have like over, I think 280, 300 videos on here. And they're all identified by the date, the unit number, and the topic. Okay, all right, so let's zoom back to here. Okay, files. Excuse me. Under files, there are more stuff under files here. If you look at the project, these are some examples of prior projects. Basically, it is a poster and in some kind of organic or biochemical. And it can be anything from, oh gosh, there's so many topics here. Things like the biochemistry of dying. What does your body go through when you die? Why does rigor mortis set in? Hormonal stuff, drugs, lots of stuff. Typically, if you do it on a black background, when you put paper on it, it pops more than a white background. And it's white on white with a white background. Now you're going to be this is during the recess is when I'd recommend you do your project. It is due between now and the end of the semester. It doesn't matter when you turn it in. Some students on spring semester did it the first week of class because they were least busy during the first week of class. They could get it over with, which is fine. Or you can wait till the last week. So there's no due date other than have it in by the end of the semester for your project. And I have lots of examples. So you can go through these and have you guys heard of crocodile? It is a really bad drug. Anyway, then there's a 1,000-word essay that goes along with it. And think about the poster as the multimedia part of your essay. So all the text and explanation stuff is going to be in the essay part. Okay? All right, and those are under files project. You look at test related. Here are some practice tests. You can see these from, some of these are pretty old. Anytime now. There you go. Okay. You have structures, naming structures, drawing structures, reactions. Now the tests are, you're going to have 3 hours to do these tests. You're going to be doing them in lab. The test is designed to be about an hour and a half-ish test, but you'll have a full 3 hours. So if you have an accommodation for longer test time, you'll have more than enough time. This one I gave extra time, 2 hours. This was done up in Washington. So what I do, how I create a test is I go through a practice test like this and modify the structures, modify the questions. But basically the length is going to be very similar. The type of question is going to be very similar. The complexity is going to be very similar. And no surprises. If you can do the practice test, you should be doing fine. And I'll provide a key. I'll pick out one with a key, and so that when you practice it, you know what you're doing, or you'll know what if you're doing it right or not. Again, that's under test related. Now, sometimes I I will always post a study guide, which is basically the practice test. Sometimes the tests are online, and there you'll find those under quizzes. And I will make those visible to you when the time comes. Okay. I'm going to be having PowerPoint presentations that I'm going to be talking through. I call them slides, and those are available under Files, Unit 1 Slides. And for example, so before the Zoom session, I'd recommend you taking these and printing these off so you can take notes on them as I go through them. There's
Wait, I have a question, Professor.
Yeah.
So, oh, the slides that you were showing, do we need to memorize all of the stuff that you have on the slide?
not all of it.
Okay.
You'll see in the Unit 1 is, everyone thinks Unit 1 is hard when they're taking it, but actually it's going to be the easiest unit of all of them. But once you get in the hang of this, you don't have to memorize everything, because it basically is going to be very logical. For example, on naming, you'd have to know, mono, di, tri, tetra, that kind of stuff. But you're going to use it so many times, you don't have to memorize it. So it seems like a lot, but it is a lot. It's just that you're going to be using it so much that you're going to automatically know it. I'm not saying you should not study for the test, but you definitely will have some amount of material to know. The last test, it's going to be open notes.
The final?
Yeah.
Okay. And the final, is it going to include everything we learned throughout the semester, or is it only going to include the test 5 only?
It's going to be 90% test 5 or unit 5. And see, the thing is, every unit builds on the prior unit.
Mm-hmm.
So unit 5 automatically includes units 1, 2, 3, 4. Unit 3 test automatically includes units 1 and 2 built into it. So that's why test 5 is our official final.
Okay, sounds good. Thank you.
Sure. Okay, so worksheets. I have lots of worksheets, as you can see, for Unit 1. So if you want, some people like extra problems to practice, and I provided those. I learn I have to repeat everything for me to learn anything. And the older you get, of course, that gets worse. But anyway, for example, I play the guitar and play the piano and stuff, and it's very hard for me to memorize music. I have to practice it like tons before I can memorize it. And I don't retain it very long either, unless I keep playing the same thing all the time. And so I have a lot of students who learn the same way. They want to practice, practice, practice. Excuse me. So I provide lots of practice for them, assuming they learn like I do. However, there's some students that don't learn that way. They look at something, I got it. That's it. So different people learn differently. So I try to provide as much help for you to learn the material as possible. Also, there are, if you belong to any of the groups on campus like MESA or one of those groups like that, they also provide tutoring, and the library provides tutoring as well. So, and of course, if you're in a study group, which I highly recommend again, that'll also help a lot. And then, of course, you always have me asking me regarding, something or other, and we can either set up a Zoom session, or you can send it to me a picture, then I can respond via an altered version of your picture, and we can go from there. So there's a lot of material here. It's not as bad as anatomy, physiology, but there's a fair amount of material you have to know. Okay, let's see. Okay, so that's files. Here's the lab safety contract, and also the release. Now, if you go to assignments, now everything you turn in this class is going to be a PDF file. So when you click on this, for example, it's going to, let's see, what does it say? It says start assignment or something like that. Anyway, I've set it up as a file upload. So you are going to be prompted for a PDF of the lab safety contract that you've signed, saying you've agreed to the safety contract, etc. So you need to have an app on your phone or a flatbed scanner to scan your dry labs and scan your lab notebooks. Now, when you scan your labs, they're going to be multiple pages, not just one page. So your scanner app has to accommodate multiple pages for one PDF file. So don't send me a PDF per page. It takes me forever because I have to download it and merge it back. And if you've turned it in with 5 pages and I give you a 0 on it, that's your cue. And I'll give you a comment. That's your cue to convert it to one PDF file. And then resubmit it. Okay, anyway, so I've set up all the labs, including the safety contract and the waiver, as an online file, and I usually give you a week for each lab. So this isn't due till September 4th, next week. Okay, your grades. Now yours is going to be just your own name here, where I have the whole class's name. But I don't know if you're aware of this, but Canvas allows you to put in test grades. So for example, say we're at the end of the semester and you want to know what kind of test 5 score you're shooting for. You can actually put in a test grade and it'll show you your percent. Like say you're at a 90% on test up to test 4, coming into test 5, and you put in like what if I got an 80 on that? And then it'll show you what your percentage is. And by the way, I do round. So if you get an 89.5, I round up to 90. At an 89.4, it stays at an 89. A lot of teachers don't round, but I do. Okay. Now you'll see your individual lab sections. Don't use those. Always use the lecture version of Canvas, because that's the only one I put material into. Okay, are there any questions about Canvas? Okay, all right, let's. Okay. What I want to review, I don't know how long it's been since you've had a 305 class, but who's had a 305 class recently?
I did.
Okay. Is your name Gia?
Yes.
Okay. Did you go over Lewis dot structures in there?
Yes.
Oh, good. Okay. What I've done is I've simplified the steps to do a Lewis dot structure. And I've included the main chemicals you're going to run into for organic and biochemistry. Carbon, nitrogen, oxygen, and hydrogen, sometimes halogens. Mostly the first four, though. Okay. Lewis dot structures involve valence electrons, both pairs and singletons. And if you go through the main ones I listed, yeah. Nick, did you have a question?
No.
Okay. All right. These are the valence electrons for most of the organic structures we're going to be dealing with. Not so much boron. I included this on my this worksheet series I include for my 305 equivalent at Sierra, which includes boron. So it's on here, but it's done the same exact way. Okay, so valence electrons are electrons in the outermost orbit. So if we look at carbon, carbon has how many electrons? Got 6 electrons total. In the inner orbital, there are 2 electrons. In the outer orbital, there are 4 electrons. Only the outermost electrons are called valence electrons. These guys, all the orbitals inner to that outside one are called core electrons. Core electrons are extremely stable. And they do not react. No exceptions. They don't react. Things in the universe go from unstable to stable. And they give off energy. So if something is already stable, there's no reason for it to become unstable. If you want to move it to something unstable, you have to provide energy. Okay, so because of that, the core electrons, because they're so stable, they don't participate in any reactions. However, valence electrons are unstable. Hence, they want to become more stable. They do that by reacting. They react with something else. So, for example, if we went into nature and wanted to find a single carbon atom, it would be horrendously difficult to find because carbon by itself is very unstable. Why? Because it has 4 valence electrons. So the goal in reacting is for the valence electrons to merge with other valence electrons in other atoms to go to 8 electrons. You would call that an octet. Except for hydrogen. Hydrogen has one valence electron. You see it over here. And it can only gain one electron to become more stable. And that's because the shell can only take 2 electrons. Everything else is going to be 8 electrons. So any of the compounds we have up here, the goal is to merge with another compound so that their singleton electrons and pairs of electrons equal 8 electrons. That's the goal. When they achieve 8 electrons, the compound becomes very, very stable. So if we were looking for carbon, the only way we can find carbon in the universe is to find it bound up with something else. Could be 2 other oxygens, for example, carbon dioxide. It could be 4 hydrogens forming methane, but it's always, without exception, always bound up with something else, even itself. Charcoal, for example. Charcoal's bound up carbon. Diamonds, bound up carbon. Now, sometimes those electrons, the valence shell electrons, are either singleton or paired up. If they're paired up, they have to stay paired up. If they're singleton, those are the ones that want to become paired up with another chemical. Okay, I gave you a worksheet here with answers. So everyone should get 100% on their first dry lab. So I'm going to go over those, show you how to build up a Lewis dot structure. Okay, so keep these in mind now. So I'm going to be building up, oops. Let's build, now you're going to become very familiar with that chemical there. It's called methane. We're going to talk a lot about methane on Wednesday. It's called an alkane as a subclass of organic compounds. Okay, so let's build up methane. Okay. So carbon has 4 singleton electrons. Hydrogen has got 1. So let's now go over to methane. So we've got the carbon in the middle. Now, one of the steps on that sheet I just showed you, I'm going to go back to it in a minute, is put the most complicated in terms of singleton electrons in the middle and surround it with chemicals that only have 1 singleton available to bond. Remember, the singletons are what is bonding, not the pairs. So carbon's got 4 singletons. That means it can bond 4 bonds. So we have hydrogen, 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 hydrogen. That's why methane has CH4 hydrogens. Okay. Then next is you have to bond everything, 2 singletons together to form a bond. Now the next question you ask is, and again, I'm going to go over all these steps. I wrote it down for you. The next question is, are there any leftover singletons available? No. Okay. Then the next thing you do is count. Does carbon have 8 shared electrons? 2, 4, 6, 8. Yes, it does. Does hydrogen have 2 shared electrons? Each one does, yeah. So this is a legal Lewis structure. Legal. The next thing you do is replace the double or the bonds with a solid line and rewrite the structure. So that's the structure for methane. And it actually looks like this. We looked at the three-dimensional version of it. And this is called a tetrahedral. And you went over that when you studied the VSEPR way to write out structures. Okay, so let's look at these steps now. Okay, excluding hydrogen or halogens, because halogens have one singleton, hydrogen has one singleton. Okay, by putting the atom with the most singleton electrons in the center and arranging other atoms around it. That's why we put carbon in the middle with the hydrogens around it. Connect all the atoms together with a pair of singleton electrons, making one bond. Move the electrons around to achieve carbon has 4 bonds, nitrogen has 3, carbon has 2, keeping the electron pairs intact. All atoms except for hydrogen must have a complete shell of electrons. Actually, when I say complete shell, hydrogen needs 2 electrons, everything else needs 8 electrons. That's what the complete shell is. And when you get into more advanced Lewis structures, you can have 18 electrons and more in these shells. But we're not going to do any of those. Okay. Make sure that they have 8 electrons. If they don't, it's not a legal structure. So number 4, number 5 have to be met before we can determine it. Okay, because carbon has 4 singletons, it can have 4 bonds. Nitrogen has 3 singletons and an electron pair. That means it can have 3 bonds. 2 bonds for oxygen plus 2 electron pairs. Hydrogen's 1 bond, the halogens have 1 bond. Let's see, does anyone have a question? I thought I saw a chat. Okay. And then for each bonding pair, replace with a solid dash. Now, if we go back to good old methane, methane is a very simple molecule. It's also a very stable molecule. Now, natural gas is where we get our methane from. Natural gas is the stuff that is in a pipe. Your gas stove at home, if you have one, your hot water heater is gas fired, your gas furnace is gas fired, and they all run on this. Now, if you have a gas leak, it smells. What you're smelling is not methane. They put something in the methane gas to odorize it, and it's that's what they odorize it with. That's why it smells. Okay, so let's do one more. And okay, C2, that's a 6, even though. Okay, so let's do the Lewis structure for this. Okay, I'm gonna put the carbon in the middle. Next, we have to place the oxygen someplace. Let's just take it over here. And then we have 6 hydrogens. Okay, then we connect every single atom at least one bond. Okay, so here's one, here's one, here's one. Now we have an interesting deal here. If I connect these two together, that will isolate the oxygen. Can't do that. We cannot isolate one of the atoms. They all have to be connected. So we're going to connect up to this guy. And then the hydrogen is going to connect up to the other singleton on the oxygen. So do an analysis. Do we have any singletons left over? No. Let's count the octets. Okay, carbon here has got 2, 4, 6, 8. This carbon on the right, it's got 2, 4, 6, 8. The oxygen's got 2, 4, 6, 8, counting the pairs also. And hydrogen has 2 apiece. So this is a legal Lewis structure. And this, by the way, is drinking alcohol. Called ethanol. Okay, are there any questions about drawing Lewis structures? You're going to be doing a zillion of these. And that's why I'm reviewing this, because it's really important to understand how to do this. Okay, now I'm going to use this as a segue to the next part. Organic chemists and biochemists are basically somewhat lazy regarding structures. Hydrogen is something that is in everything. It's the most common element in the universe, and so, consequently on Earth as well. So anything we find around has hydrogens built into it. So what organic chemists and biochemists do is they just don't write the H's. So another way to write this would be that. Now, we know full well that carbon has 4 bonds. 1, 2, 3, 4. And those have hydrogens on it. If there's no nothing attached to the atom, we're going to assume it's hydrogen. Except if the hydrogen is attached to oxygen, nitrogen, sulfur, or phosphorus. Then you have to show a hydrogen. Now, organic chemists even take a much bolder step. And because carbon is so abundant everywhere, it's ubiquitous. They don't even write the C stem. That's ethanol. Now, on the lines, there's a beginning and an end. At the beginning of the line is carbon. At the end of the line is a carbon. say we had 3 carbons in a row, it would look like this. So carbon, carbon, carbon. So this is the beginning, end, and then the kink. So for each kink, there's also a carbon. So frequently in biology books, you will see fatty acids that look like that. For example, when they show membranes and stuff, okay? And that's how they got that line drawing. Okay, beginning, end, kink. So this would be a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This would be 11 carbon fatty acid. So these are called line drawings. So once we practice doing Lewis structures, we then are going to convert them to a line drawing. So the deal with the line drawing is okay, the beginning, the kink, that's an I, and the end are carbons. Now you can have one carbon, it's going to look like this. So that's beginning and end if it has just one carbon. This happened to be an alcohol. This is called methanol, which is our third subunit in Unit 1. Okay. Also remember that line drawings can be rotated. If we go back to our 3 carbon alcohol, you can also write this like that. So we have beginning, kink, end, beginning, end, kink. Same thing. These are all the same molecule, just twisted in space. My dogs are at my feet right now. That's one of the few things about online stuff. You get to have be surrounded by your pets. I have 3 dogs. Okay. So let's practice. Yes, you have a question.
Can you hear me?
Yes.
Okay. I was just wondering, how would you draw like carbon dioxide? Because carbon would be in the middle.
Let's do carbon dioxide. Carbon dioxide, right?
Mm-hmm.
Okay. So you just told me to put carbon in the middle, right? I'm going to have 2 oxygens. Let's just put them on left and right. You can put it on top and bottom if you want. It really doesn't matter. And now these pairs need to stay together. And notice I was able to move the pairs around. As long as they stay paired, it doesn't matter where they're located. Okay. So are we okay so far?
Yes.
Next step is to connect up all the atoms together with at least one bond. So that's one there. One there. Okay, next question is, are there any singletons unbonded?
Yes.
We gotta bond them now, because those are called free radicals. Free radicals are extremely unstable. And what they do is to become more stable, they immediately bond with something. So since carbon dioxide is very stable, then it has no unbonded single electrons. So here's a couple here. And here are a couple here. So now we've attached and shared all the singleton electrons. Are you okay so far?
Yes.
Okay. Now, let's look at the octets. Okay, carbon's got 2, 4, 6, 8 electrons, right? Oxygen has 2, 4, 6, 8, counting the two sets of pairs. The oxygen on the right also has 8. So this is legal. So now we put lines there. So what it looks like is that.
Okay. Yeah, it makes sense. And then for lining, like that one that we did earlier, I'm just wondering how it would look since carbon is only, I don't know.
Well, carbon dioxide kind of looks weird. Okay, with the single carbon, then you're going to have it like this.
Oh, okay.
Yeah, the
Okay.
one carbon stuff, I usually put a dot there. Sometimes books don't put a dot there. They would write it like that. And this makes sense to me. This looks like something's been left out.
Yeah. That makes sense. Thank you, Professor.
Sure. Okay, so so how are we doing on time? Okay. What I have is practice. So this is going to be your dry lab 0. And you're going to get 10 points for doing this. And the cool thing is I give you the answers. Oh, one other thing. Notice here, I said 2 structures. Sometimes there's more than one legal Lewis structure. And when you're doing legal structures for Lewis, it's important to understand that they're legal in the sense of drawing a Lewis structure, but they may or may not exist in nature. But that doesn't mean they're not legal, though. So when you draw legal structures in my class, it doesn't have to exist in nature as long as it's legal from a Lewis drawing perspective. Now I'm going to show you these 2 structures for this guy. And so this is, we already done one of these. I wrote this formula as C2H6O. And what I did as an example, we had okay, so that's the line drawing equivalent. Okay, there's another legal structure is if we don't put the carbons exactly in the middle, but we put the oxygen in the middle, instead, when the carbon's out here, oops, let me just, Okay, so we do one line, and one bond, and then we have 6 hydrogens. Okay, no singletons left over. And so what this looks like is going to be like this. And the line structure would look like this. It's kind of weird. Now this is called dimethyl ether. And you could have 2 oxygens in the middle as well. That would be called dimethyl peroxide. So sometimes there's more than one legal structure. So if I asked you on a test, draw a Lewis diagram for C2H5OOH, and you drew one or the other, that would be fine, unless I told you to draw 2 structures like I did here.
I have a question. Sorry, Professor. So we don't write H or C unless it's oxygen and hydrogen together.
Yes, you mean for the line drawings?
Yes, on the line drawing.
Yeah, yeah. I was about to say something I forgot. It'll come with me. Okay. So this set of worksheets we're going to do in lab today or Wednesday. If once I start lab, you can, if you feel like you've already done this and want to do it at home, you can leave. That's fine. I just want to be around to help you on dry labs. I'm going to give you the answers. Now in this Lewis structure series, I leave the carbons and H's on. But because we're in an organic class, practice the line drawing versions as well. So first do it with the C's and H's, and then do it with the line drawings. Yes, you still have to go to lab. A dry lab will start off in the lab. You know, the one question was regarding the link. I did send out a message today as well. I sent it out on Saturday and sent out another one out today before everything started. The link to, are you talking about the Zoom session? Person that asked me about that. And the waitlisted person I need to see in lab, and I'll get you in.
Professor, since we can't buy the lab manual yet, you will be providing us with the worksheet today.
Correct.
Okay.
I'm going to give you a packet. Well, assuming the print shop printed them for me. I'm going to make that assumption. Yeah, it'll be a packet of a lab 0, 1, 2, and 3.
Okay, thank you.
What is a Discord group?
Discord is basically like where students from classrooms can get together and kind of study together. And they help each other out outside of the classroom.
Oh, like a study group then?
Yes, yeah.
Oh, cool. Yes, could someone do that? It doesn't have to be one big one, it can be, smaller ones as well. And then Edgar, you said, can we see what grades people got, that we know are good and bad examples of what?
I think he meant the project.
Oh, okay.
Yeah, that was a while ago. I'm good on that.
Okay, well, those are good examples, the ones I have. A bad one is gonna be, those I gave, some are really good and some are okay. And you can, as you go through them, you can tell which is which. The bad ones would be, a poor poster, when the poster's too small, it's not a 3-panel poster, handwritten poorly. I mean, these are easy points. It's not hard to make a nice looking poster. And you have the whole week of recess to do it. And it's the same amount of points as the tests. Yes, you need a comp book.
So just to confirm, Professor, I'm so sorry for interrupting. The project can be on anything that we desire to learn about.
Mhm.
Okay.
Try to restrict it to organic and biochemistry. When you look at some of those projects, I'm trying to remember if some were inorganic. Organic is easier because there's more organic chemicals in the environment than there are inorganic. There are millions of organic molecules and drugs and all that stuff, and there are significantly less inorganic stuff.
What if it involves both?
I'm sorry, say again?
I said, what if it involves both?
What is involved?
Like if it involves both of them, inorganic and organic.
Oh, no. It can be biochemistry or organic or both. So it doesn't have to have both in it, or it can have one or the other. Like a lot of people do caffeine, for example. And how does caffeine work in your body? What's its structure? That kind of stuff. In 305, they did, what was the project? Can someone explain the project that they did in 305?
We did it on a drug, Professor.
Okay. You were limited to just drugs?
My professor gave us a specific drug for each group, so I had Dilatin, I think. And we talked about it and what it was used for and did structures for it.
Yeah, we had a similar project where we got to pick the drug, but it was like we went through the different type of line structures, hydrogen bonding, etc. Any other interesting, like the facts and etc. So yeah.
Okay, well, I'm not going to assign anything to you because I want you to come up with something that you're truly interested in. If you're looking to get into oral hygiene school, for example, you might do something regarding dentistry or something. Or if you're pre-nursing, there's just a lot of nice topics. And the main thing is to, always include the structure, talk about the chemistry, a little bit of it, is it fat soluble, water soluble, if it's a drug, something that you ingest, what are the side effects and pros and cons, and just kind of when you get a prescription drug, when you pull the little paper out and read it, kind of that kind of stuff, where it's indicated, where it's not indicated, that kind of stuff.
Professor, for the project, do we have to get our topic like do we have to show you before we work on it, or just anything related to like the chemistry stuff we talked about?
It would be better if you just mentioned it. Is this okay topic? I just want to make sure you're, not off doing something off the wall. So yeah, just run it by me. You can either text me, or you can, after class or before class or something, or even on the Zoom call, or just say, is this okay? And I'll, like one person did it on, she played the violin, and she did it on how the varnish affects the tonality of the instrument, different varnishes. Another was a guitar guy, and he talked about the corrosion on the strings. It was just really, another person did it on what is when a body dies, you get something called rigor mortis, where your joints are very stiff and your muscles are very, very tight. What's the chemistry of that? And some people did it on hormones. There's just a super variety. I learned about Manuka honey from one of my students who did a poster on Manuka honey. And Manuka honey is the honey from New Zealand from the tea plant. And it has tons of medicinal purposes. It's got an antibiotic built into it. It's got anti-inflammatory. It's just really nice stuff. And you can get gauze with Manuka embedded in it. I bought some when I was living up in Washington because my wife at the time had some issues, and she used to put it on her skin. If you get burned, for example, even slightly or severely, they frequently will use Manuka on it. I didn't learn about it until a student did a project on it. So I get to see all these really cool ideas. So I enjoy looking at everyone's projects. And because I do it wide open, so you can do anything you want. It's nice because there's a lot of times they come up with ideas that I never would have guessed, like Manuka honey, for example. So.
Professor, I had a quick question.
Yeah.
I'm looking through the Canvas modules. Where can I find the details of the lab description on here? Under files, mayhaps?
Under the write-up?
It's so it's under modules, and it's gonna be under write-up.
Yeah, let me get out of this and go over to.
Okay, I think I see it. The video.
Yeah, I have at least one video there, and you're gonna have another one here as soon as I do it. I'll probably do it next Wednesday because Monday's a holiday. Yeah, this is it here. But if you go over to pages, actually, pages is where is the intermediate place where all the videos go through. So these are all the videos that I reference from modules. So here's another one here. And it's just I'm smiling. Okay, what I want to do is talk to you about the lab, pre-lab, and lab write-up itself. It's a very important part. So I have a number of them. So there's three sources of kind of stuff: modules, files, and pages. Modules points to pages, but pages has more stuff than modules. And then files, Modules also calls up files. So between files and pages, that's a subset of modules. Usually I don't talk about pages because all you need to do is go to modules. Files has extra stuff like extra worksheets, where are the slides involved. For example, you know, when you go to Unit 1, on Wednesday, we're going to be doing this here is on alkanes. You can look at this one as well. Or you can look at this one. So there's multiple versions of the videos. And theoretically, I cover the same materials, but usually I do it slightly differently each time. I may give a different example or whatever. So, you know, if you're going to repeat watching the same video, you might want to look up another version of it. Okay, how are we doing? Okay, well, I've covered everything I wanted to cover today. So if you want to have a digital copy, one more thing here, a digital copy of the labs, if you go to Files, Lab Related, like here's Dry Lab 0, Dry Lab 1, Dry Lab 2, Dry Lab 3, here's the waiver. Now you can do them electronically if you like. You don't have to scan a page and do it on paper. You can do it electronically if you want. That's fine. You're still going to have to save it out as a PDF file though. Either way, either it's on paper, fill it out, scan it, or it's on digitally available in a tablet. That's fine. Save it out as a PDF file, and then when you click on the assignment, it'll prompt you for a PDF menu. So if it's on your phone, you need to get it over to something so you can access it on Canvas. You should be able to do that from your phone. Also do it from a tablet, and also do it from your computer. There's a lot of ways to get at this. Okay, so it's important to show up for lab today because I want to hand out the packet of labs. Someone's waitlisted and wants to join our class. Okay. So, any more questions?
Do we need our lab book in lab class?
Only for wet labs.
Only for wet labs. Thank you, Professor.
The dry labs are worksheets, so you're going to do them right directly on the worksheet or do it digitally. The wet labs you got to do in your notebook though. Now you can do the wet labs in a tablet as well, but it's the same amount of work. So I'm not. A lot of my students at Sierra and Sac City use tablets, and personally, I think it's easier just to do it in a lab book because you got to print it out anyway. And for me, it's more awkward on a tablet printing because there's no copy and paste. It's all handwritten. And whatever chemistry class you take, of course, you're not going to take any more if you're in 306, but if you're taking 400 or 401, they all do this. The lab notebooks are all handwritten. 420, 421, all those are same way as I'm doing it. And I don't know why 305 doesn't do that. Those of you who have taken 305 here, who's taken it last semester?
just took it over the summer.
Okay. Did you have a lab write-up or did you just do fill in a questionnaire?
We had a lab manual, but we didn't have to do like a summary write-up or anything.
Okay. Would you just have the data table in?
Yeah, so we had to buy like a lab, like I said, like there was a lab manual we had to buy. It had yeah, so there was like data, there was like a table, there was like questions to fill out. But there was like no summary of like this is what you've learned today or whatever.
Yeah, okay. Okay, well, anyway, what I'm gonna have you guys do is a very, very common format for doing lab write-ups. And I've worked at probably 6 schools, a number of them up in Washington State and 2 down here. And they all do the same thing, except for 305. And I don't know, because the person that's the department head is in charge of 305 and 306. That's Joel Huang. And he was surprised I had my classes do a regular write-up. I said, well, they're in a chemistry class. It's just like what everyone does. Well, anyway. So okay, well, I'll tell you what, there aren't any other questions. Why don't we end this and I will go ahead and upload this to modules. It's going to take a little while to render and then it's going to take a while to upload. So I should be at school earlier than 2:30, but for sure by 2:30. Any last questions?
Yeah, sorry. If we're on the wait list, do we have a high chance of getting in since there's
Yeah.
so few?
Yeah. Show up to lab.
Gotcha.
Logan, were you waitlisted?
Yes, I wasn't on the canvas.
Okay. So did someone tell you about this link?
I believe I messaged you directly and I was given this link. I emailed you.
But the message should have gone to people only in the class. So are you enrolled in the class?
I'm pretty sure I'm on the wait list. I'm not on, it says I'm waitlisted on e-services, and also when I go through my Canvas, I don't see Chem 306.
Okay.
So I'm not necessarily sure. We'll talk about it when I come to lab.
Yeah, I'll give you an ad number.
Okay. Thank you.
Okay, I'm going to go ahead and end it unless we have any more questions. All righty. I will see you guys in a little while.